Thanks, community, for joining us for a fantastic panel here. And incredible practitioners and folks from deep backgrounds from the earliest days of applying machine learning in finance and fair lending. Without further ado, let's get to a round of introductions. Nick.
So thank you, Sri, and thank you for inviting me to be on this panel. It's very exciting. And so my background is I'm a statistician and I work in regulatory and legal compliance. I run the AI practice at a small consulting firm called BLDS. And we develop tools to help companies ensure that their AI is fair and non-discriminatory. And in that, what we do is we use standard regulatory approved and understood metrics to assess fairness. And if there are issues, what we do is break open the black box, figure out what's driving any potential issues that are going on, and then try to find an alternative model that gets rid of those negative factors and brings in as many positive ones as well in exchange. And what that ultimately will do is create a model that's fairer, highly predictive, and enables a company to extend its footprint and gain additional market share.
Thank you. Raghu.
Thank you, Sri. First of all, thanks for arranging this webinar and also having the vision around getting all of us together to write this paper, so truly appreciate it. About my background, I have a PhD in applied economics with a master's in industrial engineering and operations research. Most of my life I have spent it in Discover Financial Services in various modeling areas, right from AML to loss forecasting to collections modeling, and now back to scorecard modeling. And I also have spent in model risk management. Happy to be part of this collaborative effort with industry leaders around this paper, and looking forward to this webinar.
Thank you for joining. Steve?
Hi, Steve Dickerson. I'm the Senior Vice President of Decision Management and Chief Analytics Officer for Discover Financial Services. My PhD in economics from the University of Arizona. And actually my first role in the industry was as an econometrician for one of our competitors. And I just wanted to kind of take a minute here to thank Sri for the support of the project. This all started at a roundtable that H2O set up for us after their annual meeting, H2O World. And the purpose of the roundtable really was, eventually the paper was to elevate the language around explainability, bias, fairness et al. Because we really saw a lot of unprecise language going around these concepts. And so, starting there and then ending up with this very core group, I think we actually put together a pretty nice paper that actually went well beyond that initial purpose of the paper. But thank you, Sri, for your support. It's great to be here.
Thank you. I mean, customers have been a guiding post for us in building the company and building the products around the company, but more importantly, building the language in with which we can exchange ideas. I think this document does a fair bit of legwork there. Patrick.
Hey, everybody. Really glad to be here. And my background is I spent about 4 years working with Sri to make one of the first commercial offerings for interpretable and fair machine learning, and also some model debugging in there. And I'm very thankful that Sri provided the kind of open, creative environment it takes to do that kind of thing. Recently, I've been more focused on sort of policy and compliance issues around machine learning. And at a law firm I founded with a partner called H2O.ai, and I'm also a visiting professor at George Washington University.
Ben?
Hey, thank you, Sri. My name is Ben Cox. I'm Director of Product Marketing at H2O. Before I came here, I sort of kind of fell backwards into the space. I was a consultant doing AI strategy consulting, and I realized that a lot of our customers, when thinking about the economics of their AI adoption curve, weren't really asking the right questions. And that was from kind of a human and organizational change perspective. But when you get under the hood, you realize that statistically there can be a lot of problems too. So I really started to lean into the explainability, interpretability, how can we start to make models more understandable? And these types of papers matter a lot, because I think there's a famous lecture on 23 definitions of fairness, but that doesn't really hack it in industry where we need to have an agreed upon definition of certain things. So, the opportunity to put forth kind of ideas and proposals, I think matters a ton for practitioners. So thank you, Shri.
Thank you for joining us. And lots of incredible set of questions have piled on in the last few weeks of the panel announcement. So we'll probably go to the audience question halfway through. I have some for the panel. So let's dive in. Raghu, you are a strong proponent of having a very defined terms of glossary and ways to communicate between banks, between institutions, between practitioners. Practitioners like Lick, practitioners like ours, H2O, building products. What is the goal of the paper, and probably how do you want to extend it in the future?
Thanks, Ray. I will start, and Steve, please chime in as needed. And when we started this journey, maybe a year and a half ago, there were a lot of terms floating around interpretability. What does it mean? There were a lot of terms around usage of postdoc explanations of models. And there were a lot of terms floating around on the fairness and evaluation of fairness within the models, pre-production and post-production. All of them were good terms. All of them, everybody is motivated to doing the right thing. And we are also in the same boat. What we wanted to do as a team is kind of talk together as a community about these emerging terminologies. Because as we evolve in this machine learning world, there is a need to kind of come to a consensus about what does interpretability mean, what does fairness evaluation mean, right? What do these terms mean, and go a little bit beyond that, right? Get a little deeper into what are the techniques out there, what are the global methodologies out there, what are the local methodologies out there, so on and so forth. So, when we attended the H2O World, we came across a lot of practitioners, and I happened to meet with both Nick and Patrick at that point in time. And it was actually Steve's brainchild also to kind of come together and start writing a document which at least attempts at all things related to machine learning algorithms, which help us in financial industry. And we say machine learning AI, at the end of the day, it is more static and supervised learning. So we wanted to set the record straight and kind of talk about the reality of the situation, and kind of have that starting point. Steve, I don't know if you want to add anything to that.
Yeah, I'll pull us up a little bit and just say that the power of these algorithms is really impressive, and we're going there very, very quickly. But the foundational regulatory environment of consumer financials is around fair lending, right? So at some point we have to marry these two, and if we're going to be successful at the game, we need to bring our regulators along, right? So part of this was not just to get a common language across the institutions, but also get a common language with our regulators. And just quickly, for those of you that are outside the consumer financial sector, you're going to end up with the same kind of set of problems, right? And the objective functions that you're trying to solve are adjacent, right? So anything that we can do on interpretability or explainability, we'll get into that probably, is immediately can be used on one of the adjacency problems, whether it's self-driving cars or et cetera. But that was kind of why we got together.
I can kind of piggyback off Steve's comment quickly and say that I agree that I think that financial services, consumer credit, some employment, other applications are probably just the first people to have to deal with these kind of regulated issues in machine learning. The FTC in April released a very sort of broad document on AI guidance in general that doesn't call out special sectors of the economy and likely forecast sort of or telegraph sort of, you know, future broader regulations.
And if I may jump in, I completely agree with what they were saying. And in particular, where we are seeing a lot of activity is in healthcare. There's a recent paper that came out in Science magazine, co-authored by a couple people from the University of Chicago, Ben and my alma mater. And what it found was there was tremendous discrimination in an algorithm that was really quite horrifying and led to death. And we were hired by a major health insurer to look into their algorithms and set up a model governance platform. And we are using what is currently done in financial services as the baseline for moving into other industries. Because what financial services does is the best. Most firms within financial services have the best model governance, most effective, most deeply sourced and thought out. And so if you are, as the audience members, if you are working in these areas and you're new to them, I highly suggest looking to the work that's already been done by people like Steve and Raghav, because it's foundationally exactly where you should go.
Yeah, and I would piggyback on that by saying, you know, a lot of firms like early on in adoption have the opportunity to kind of start off with best-in-class infrastructure around responsibility. Whereas, you know, X amount of years ago, we didn't know. There was a lot of research going on how to be better, but right now we sort of have some best-in-class practices that we're trying to do, you know, that we see in finance or that we start to see in healthcare. So you have the ability to kind of reduce future technical debt as an organization, which is a really good opportunity to sort of see the future before you're there.
And I would just jump in there and just say the FRB has been our partner in developing the strong and robust model risk management programs that we have in the financial sector.
I think, I mean, it would be remiss to not add the rest of the H2O customer community, especially folks like Agu Sujanto from Wells Fargo and folks from Synchrony and Citi have been quite, Capital One have been quite, I mean, they broke some early ground with regulators, with software. I remember even folks like practitioners from Dun & Bradstreet and others asking us for different implementations and improvements of Shamply, Lime. And over the course of the last 3-4 years, our close collaboration with our customers has been quite an incredible opportunity to improve machine learning interpretability in driverless AI and H2O open source. I was going to jump into some glossaries. Maybe we go in a fast 10 minutes around the paper or different parts of the paper. Disparate impact versus disparate treatment. Who wants to go for that?
I'm happy to.
That's a Nick question.
Yeah. So this is incredibly important, and for people who are not familiar with this can be the difference between you and you're worried about regulators. This will be the difference between spending, you know, a couple $100,000 getting it right in the early stages, or spending $100 million in a settlement like Facebook had with HUD. So it's really important to get these foundational issues correct early on. And there are essentially two different types of discrimination that are recognized in the law, in credit and housing and employment. One is disparate treatment, and that's what we probably all think of when we think about discrimination. And it's, I am not going to hire Patrick because he's a white man. Now, that's generally not the place that
Probably smart.
you see discrimination. Yeah, there are many other reasons why I would not hire Patrick, but it's explicit use of a protected class status, and that is just straight up illegal and straight up wrong, and case closed. The other is disparate impact, and this is more controversial, and it's the idea that you can have a valid factor. It's predictably valid, reasonable, but the usage of it ultimately leads to a protected class, and by a protected class, I mean, say, African Americans, Hispanics, Asians, older people, women. That factor leads to outcomes that are less favorable for that class. So if you look in lending, for instance, almost any lending model, credit model, is going to give fewer offers to African Americans and Hispanics relative to whites and Asians. It's a fact, and there are many reasons for that. And if it's disparate impact, it's telling you that is an example of disparate impact. And there's what's called the burden shifting test, and this is used in litigation, and it's something that we apply with our clients, where we say, why don't you keep yourself out of trouble? Don't get in trouble, keep yourself out of trouble, and try the burden shifting test yourself. And so the first thing that we do is calculate, is there disparate impact? Are Blacks receiving loans at lower rates? And if they are, it goes on to the next step of the burden shifting test, which says, are the models valid? Now in credit, and this goes back to my earlier comment about credit being kind of the best example, these models go through model governance that is sufficiently strict that, with very rare exceptions, they're good models. They pass the smell test. They're predicting what they should be. And so we kind of can skip over that step with credit models. Other places, not true. Employment algorithms are oftentimes not effective, shall we say. So once you get past the validity test, you then get to a question of, are there alternative models or processes that would have less disparate impact, but still be predictive? So can you move up that rate of African Americans or Hispanics getting loans? Can you go from 10% of African Americans getting loans to 11% without significantly decreasing the predictiveness of the model? And that process answers the question of whether or not disparate impact discrimination is legal or illegal. And if the model's valid and you've made a good effort to find an alternative and you haven't found one, then you're done. But if you've made a good effort and you found an alternative, then you have the obligation. And if you don't implement that model, you are now in disparate treatment world. And that gets you in a whole world of trouble. And so you have to know what this process is. And you have to know that even if I experience a lot of people really pushing back on disparate impact as a concept. Everybody wants to say, not everybody, of course, but people want to say, no, African Americans default at lower or at higher rates, so we shouldn't be giving them loans at the same rate. Well, be that as it may, there's a regulatory requirement to see how much you can move the needle. And so those are the two differences in the types of discrimination.
Okay. We'll probably jump ahead to adverse action notices. Maybe that's we'll probably jump into kind of why we felt the need to kind of tighten that definition a bit. And there's a question around fairness as well, which probably will go back to Nick again at some point.
Yeah. Adverse action is at the core of how most of our financial institutions operate when it is dealing with credit lending, wherein there are chances that some of the applicants might not receive the credit which they have requested for or are trying to go for. And adverse action is the legal way of communicating with our customers or potential customers to say, hey, here are the reasons why you got the credit, or to let the population know, here are the reasons why they were not offered the credit. So from a modeling perspective or from a domain perspective, it boils down to rank ordering the top attributes within the model, or a combination of model and strategy, which have caused the decision to go against the applicant. These are mentioned more in ECOA as a legal construct, and this is at the basis of the paper. And one of the reasons why we wanted to write all the definitions around this is, again, we want to do the right thing. We want to innovate within the way we are operating within this ECOA structure. And also, we also want to use the data which are FCRA compliant. So with FCRA compliance and ECOA in mind, we wanted to first acknowledge their presence and then go from there. So that's about adverse actions.
Steve often talks about FCRA compliant data. Can you, when customers or users are trying to add additional data sets, alternate data sets, what considerations?
Yeah, we and I'll let somebody else talk about it a little bit. When we talk about alternative data set, we're really talking about alternative FCRA compliant data, right? As a banking institution. So I think it's pretty straightforward. You know, it's either compliant and you can give an adverse action reason based on the data, and a customer can call or write and get the get the background, the credit check, or LexisNexis has a big, they'll send you what they have on you in public record if it's being used for a decision. But so that's kind of the end of the road with certainly at Discover when we talk about alternative data.
Ben and Patrick, you want to take the concept of global versus local?
Yeah, sure. So on this theme of like U.S. government regulatory or just big government agencies getting involved in machine learning, NIST, National Institutes for Standards and Technology, just recently released their explainable AI draft guidance, and they do also address these concepts of global and local, and so global explanations are things that help us explain a machine learning or any model, any predictive model across the sort of a larger partition of data. So a validation data set or, all of your development data. Whereas local explanations help us understand how a model treated, they help us summarize how a model treated some smaller group of people in the data set or some smaller group of rows down to even one person. And there's lots of different ways to do this. I think, we already talked about this idea of sort of ranking feature contributions to a prediction. That's a great way. Another way is sort of visualizations of an entire model. And I truly believe that it's only when considering both global and local explainability can you get the best explanation. So I'll shut up and let Ben chime in if he wants to talk about how that sort of affects people from a business perspective or any other thoughts you might have.
Yeah, I mean, just from a layman's perspective, if you think about how a model might treat, specific classes or predictions at the aggregate versus in this isolated instance, if you see these big disparities between that, it gives you like cause for pause and lets you ask these following questions, right? I think a lot of what explainability and interpretability come to are seeing how things look globally versus locally, and then trying to like use some business context or intuition to understand why models might be kind of making predictions differently in a subset versus a larger set, right? I think it gives you the opportunity to stop and ask these questions and try to figure out what's going on under the hood of the model. Right?
And just to build on that, Ben and Patrick, the concept of global and local can also be extended by looking at data local and data global versus value local and value global. And what we mean by that is within the data set, we have, let's say this whole group is a data set. My average utilization of credit might be different from the other people, but it's within this concise, within this data set. So in the previous world, we used to use the deviation of at an account level, what the utilization was versus the average utilization. So that kind of forms the data local and data global aspect of viewing the interpretation. And then the value local is really with the proliferation of gradient boosting or random forest type of algorithms, we have many more attributes which end up in the final model, unlike the traditional models wherein we had more stricter rules for correlations. So here, because there are more variations of attributes which might end up being correlated, thank you, Shri. So I'm talking about the top right table is when you have attributes which are more correlated with each other and end up in the final model, you do want to have a way to look at what is really causing that incremental performance in the model, right? So one example could be that if you have delinquency as one of the attributes, we slice and dice that attribute into recency, frequency, and monetary type of attributes, like last 3 months, what was the delinquency, 6 months, 9 months, so on and so forth. In traditional models, not all of those would end up in the final model, but in these models, especially boosting type of models, they might end up. So how each attribute then corresponds or impacts its correlation to the other attribute and vice versa becomes important. So adding local and global to your perspective of explanation and the angle of data and value would definitely help in the overall discussion around explainability.
I figured that it's not a panel on a stage. We can actually pull up a picture or two. So, the next topic that, Shamply. So how do you take straight to the? How are you using Shamply today in your global and local?
Patrick, you want to start? I can chime in.
Yeah, sure. Sorry, and welcome to my apartment, kitchen, dining room, living room, office. So I put my video on black. Sorry about that. So to me, Shamply values are probably the leading technique among many techniques for sort of summarizing individual machine learning model predictions. And Shamply values are not perfect. I'd still argue they're the best, and that especially if you're using tree-based models in some kind of high-stakes use case, you should be using Shamply values. And so Shamply values are an idea from the 1950s from game theory that took until about 2017 to surface their way into machine learning. And they just have a long track record of being useful in different mathematical modeling exercises. And there's a lot of other ways to generate local feature importance that may be valid for your given task. But Shamply values are a way to break down an individual machine learning prediction into its components. And then also there's lots of good ways to aggregate those individual prediction explanations up into global explanations. And so, it's certainly my tool of choice when it comes to explaining machine learning models, but I'll turn it over to other panelists to let them talk about exactly how they like to use it. I know, Raghav and Steve may be thinking adverse action notices, and Nick does some really cool stuff with using Shamply values to find disparate impact or other kinds of discrimination.
Yeah. The only couple of points I would like to add, Patrick, is that the explanation again boils down to the final application of how and what we want to do. So I am also a proponent of Shamply value. At the same time, we should be looking at other things like ELE or global explanations like PDP, or more local like line, whatever you want to call it, and hopefully look at what are these different methodologies saying. are they very drastically different or not? So that's where I think as an analyst, I would be more interested in at least understanding it. Then, definitely if all of them are directing towards one area, then, you have your answer there.
Yeah,
I just add before Nick, I'll pass it to you in a second. It's the concept here is that we want to make sure that there's continuity in the reason codes across the different methods, right? And if if your data is relatively smooth, it's not really a problem. Local globals give you the same answer, but if you start getting more nonlinearities and some oddness in your data, then you have to be careful because that's where you're going to end up with some discontinuities in your reason codes, and then you can't you don't have a lot of strength in those reasons. But Nick has something.
So I completely agree, and especially the idea of using different techniques. But I want to start one step before that, which is something I beg my newer employees, the people freshly out of undergrad, to do. And I think this has become especially acute in the machine learning AI space, which is open your data. Open the data set and look at it. And don't just throw it into a deep
just really
neural
quickly,
network
Nick, to back you up here, that is a responsible AI tenet from Google. Look at your raw data.
Really? Okay.
Yeah, so I'm sure you thought of it before they did, but just to make it
yes. There's one experience I had where I was working with this coworker, and he's probably about 6'7", and he's this huge guy, and we're working on a project, and he had this little laptop, and he was, for about 6 hours straight, he was just leaning over it, looking at an individual line of data, and then Googling the particular product we were looking at and getting information for it. And man, that made the report great. We learned so much about it that, and I will sadly admit that I jumped into the analysis before really looking at the data. And what came out of his work was right. What came out of me just jumping in, not right. So in addition to the explanations, and I think the local explanations really add to this, just open the data set and start playing around with it from that point, and then move to the algorithms.
I think we all would agree with that.
I'll get off my high horse now.
Talking about algorithms, explainable boosting machines and Kato VMs that we talk about in the paper, who wants to take a cut at interpretable machine learning algorithms? And
I could talk about that, Sri. One thing that Patrick and I kind of talk about a lot, we data scientists really enjoy building complicated models, always have, always will. And for a while, there was this kind of idea of trade-offs in signal versus simplicity, right? A deep learning model will always outperform, a more linear model or more GLM with more data. But what's great is that I think Microsoft just released their EBM, Python package. We build explainable neural networks. And what's great is that with tabular data, like you might see in a credit example, that trade-off doesn't need to exist anymore. And what's cool is, we built a lot of tools like SHAP, values, K1 to explain models after the fact. We're actually working backwards, like the industry is working backwards to build things like explainable boosting machines and explainable neural networks to make typically black box models more white box and more transparent, so you can kind of see what's going on under the hood, which is a really positive trend that we see in the industry. And, we try to build on top of that as much as possible.
And I'll just add really quickly, there's starting to be more and more evidence that for structured data, so for sort of, credit risk or fraud or traditional data mining applications, these new interpretable models like GA2M and EBM, and we have to mention Cynthia Rubin's work, are actually just as accurate, if not more accurate than black box models. So So we're really coming to the point where the idea of using a traditional black box machine learning model on a structured data set in some kind of high stakes application is becoming questionable, not only from sort of an ethical standpoint, but also from a just pure accuracy standpoint too. And I think that's a really important point.
And from a fairness standpoint as well, I always get the name wrong, the Rashomon. Yeah, the Rashomon effect, which I can say is the multiplicity of good models. One of the wonderful things about machine learning, and when I talk to regulators, I really stress this, is that because there are so many possible features, so many different algorithms, so many hyperparameters that you can decide on, you end up with this multiplicity of good models where you don't know if you're looking at AUC, even if you're breaking down segment level AUC and various other metrics, you don't really know which one to choose. There are a bunch of them. There are 100, there are 1,000 models that look almost identical. So what do? You can then optimize on explainability. You can optimize on fairness. And you can get a better model. And so that's great. That's a really huge advance in machine learning that we should all focus on.
Yeah, I would piggyback on that and say one of the great things, personally, I came from pure finance and moved over, that I see in this space is that practitioners work pretty grassroots to build more explainable models and more interpretable models because we know what we see in industry and we know what we're trying to kind of work back from and solve, for the sake of data science adoption and AI machine learning adoption. Right?
Great. Bunch of questions have popped up from the audience already. Notable among them is, if the data is biased, what do I do? My data is biased already.
If the data is biased, well, let's get back to this. How do you define bias? And is it biased but still predictive? And then what is the source of that bias? Or is it just straight up discriminatory? And the answer to those questions are going to lead to different solutions. If you have a model, or if you have data where the bias, the discrimination is built on the fact that America has experienced, blacks in general have experienced 400 years plus of discrimination, and that's leading to where they are today, that really is a different question. And I believe it needs to be addressed, but it's a different question than, are you including something like Reed's Ebony magazine in your model? And the responsibility of a bank is different depending on those things. Socioeconomic, things that we call pre-market factors, which are in employment, is things like your level of education. Even after you control for level of education, African Americans on average are significantly disadvantaged. Not all, and I make it clear that this isn't global, this is individual, but it adds up to an average effect. What is the bank's responsibility? That gets to the disparate impact question, where the bank doesn't, under the law, as I understand it, and I want to stress that I am not a lawyer. If you're taking my advice as legal advice, you're making a huge mistake. But despite that, I will go on. That's where disparate impact analysis comes in. And it goes to the question of, I want to get to parity, but without putting the bank out of business. If it's biased from data that is just plain not right, you're including Ebony magazine in your credit model, I don't know what to tell you other than take it out. And that's not always unfortunately, that's not a clear line. You know, what about Sports Illustrated? That's going to affect women more than men. I mean, I think any use of a magazine in a credit model is problematic, but there are other examples where it is more of a continuum. And ultimately, whether or not you're going to include those becomes not as much of a quantitative question as it is a risk management and policy question. And you have to have those discussions, and you have to have a principled basis for making those decisions. One of them is I believe it's the responsibility of any enterprise to have that conversation. The other is self-interest. If a regulator comes in or the New York Times finds out about what's happening,
Nick,
and you don't,
Nick,
sorry.
For a second, sorry to cut you off there. I was going to get others to chime in as well on other methods that they could use. Great points, but data bias is kind of the heart of the matter. I was going to see if there's any practical ways machine learners have found to weigh one versus the other. Maybe Patrick or...
Well, probably what Nick is getting at is there's no single process solution. There's no single technical solution, right? And moreover, there's sort of industry specific regulatory considerations. And so I think, you know, one guiding, you know, two guiding principles that I can say are, you know, discrimination often comes from the data. You know, the machine learning model rarely sort of magically makes it on its own, I guess, even though that's potentially possible. And then, as I've said to a lot of people in the chat, I think that laws are actually a really good guidance for helping select your fairness definitions, because there's, you know, we've said 21, 23, it doesn't matter. There's a ton of different mathematical fairness definitions. So using the law to sort of guide you in selecting a fairness definition is really important. And then, you know, this is just totally out of Nick's playbook, but you know, the safest way to deal with discrimination in a predictive model is to consider discrimination measurements, AIR, SMD, when you're doing model selection, right? So yes, there are fancy new machine learning research approaches that we'd love to talk about, but the simplest thing you can do is just say, you know, when I tweak this hyperparameter, does it change my fairness metric? When I add this variable in, does it change my fairness metric? And then pick a model that tries to minimize disparate impact or discrimination while also meeting your business objectives. I think that's the most practical and safest advice that we can give, I think. And you know, in terms of cool new machine learning research, I think we're all fans of adversarial debiasing. Dual objective functions that consider fairness and accuracy together. So sort of doing that process I was talking about manually, but doing it automatically as part of the optimization function. And I'll shut up and let others chime in, but those are my thoughts there.
Yeah, I wouldn't add a great deal more. Those are very good answers to that. But to kind of summarize, start early, look at your data, and, you know, before you get done, make sure you're going to be able to defend what you did. And depending on what industry you're in and what level of risk the firm is willing to take, that will guide you. But what was the phrase, Nick, principled reason that you used?
Something like that.
Yeah, so,
yeah.
I don't know, Raghav, did you want to add anything?
I think from a practitioner perspective, all your points are valid. I would still go back to the initial comment which Nick made. I think bias has always been there. It's not like machine learning invented bias. It's always been there with, you know, in the logistic world or whatnot. And yes, algorithms might exacerbate some of the correlations and might add or may actually reduce it. So having an analytical framework to actually look at the data set and then come to a more practical solution would be the way to go, I guess.
No, that's good. And that's the, don't let the shiny objects, you know, distract you from what you're actually trying to do, because there's plenty of new cool stuff to do. But at the end of the day, at least our firm is in the consumer financial industry and is regulated.
Yeah, and I mean, we can all pile on here. There's just no, like, there's no short answer here. There's no like, go download this package and apply it to your model and then you're set, right? Because there's just massive sort of human and process considerations here. And some of the worst AI incidents we've seen, you know, in the media were just failed process, right? Like decent technology, but horrible failed process. So, you know, there's process and people considerations here along with the technology. It's a very complex problem, as Steve and Raghav can attest to. And that's why these large financial services firms have, you know, 3 lines of defense plus other sort of process aspects going on.
Yeah, and that sort of goes back to like a point I made earlier, right? You know, even if you get some shiny new model, it doesn't matter if the frameworks around it aren't an infrastructure that supports the responsible machine learning workflow, right? At the end of the day, you can have all the technology, but if it isn't being used in a correct fashion, it's kind of for nothing, right?
Yeah. And the way I think about it is, you know, there was a time when ordinary least squares was super sexy and cool, and before computers, and people were inverting matrices by hand. Now, I don't know about the rest of you, but the last time I inverted a matrix by hand was in graduate school, and I'll say I didn't particularly enjoy it. We're in the machine learning inverting a matrix by hand phase. And I think the work that Sri and H2O are doing are going to get it past that. And it will get it so that machine learning techniques are much more like running a logistic in H2O3 or SAS or whatever it is, where these cool algorithms, like the fact that they're cool algorithms doesn't matter. What matters is, are you putting the right stuff in? Are you getting the right stuff out? And are you figuring out what's going on between those things? And I see the move towards explainable AI, towards interpretable AI, and easier to use AI, really following that pattern. And there have been some questions about how do I get into AI and machine learning? My response is go by Green's econometrics and learn that. And when you can read it, you know that you are an economist. And it's the idea that figure out the data, understand what's going in, and then you can use a tool like driverless AI or H2O3 and all the interpretability, explainability stuff, and get results that are as robust as possible.
The only thing I would add to it, your advice there is you don't have to throw your computer away, read it on Kindle or something.
Yeah. I'm over 40, and so I still like paper books.
So the odds of a Green reference being on the call is pretty low. So, you know, we got a shout out for Green. I'm going to pile on just a touch, which is, if you don't have the proper framework in place and the right process in place that Benjamin was talking about, everybody was talking about, the chances are the robustness of your model and long-term performance of the model is going to be bad as well, right? So, you know, all of these things that we're talking about can also be applied to making sure that you have a long-running, robust model. So it's not just about fairness and bias here.
The model robustness is a huge topic. Someone asked us, what are the cutting edge things that are happening in the space? Model robustness, model distillation to simpler models. How do you do adversarial testing, create adversarial data to shock your model? What is the minimum perturbation in your data to get maximum error of your model? All of these backtesting, obviously, which has historically been used, new methods of backtesting, optimizations of backtesting, scenario analysis. A lot of that is coming in the next, coming soon in the next versions of the software as well, but they are all kind of general trailheads for us. Customers are leading the way on how to apply a more measured approach to model robustness. Given that all models are wrong, some models are useful, it's still why are they wrong? Interpreting when they're wrong, what kind of meaning you can derive from when they're wrong. I think that's kind of the things that a lot of our, what can you do to fill in the blind spots? Models are like other intelligent things. They have blind spots. Can I use an ensemble method or a simpler one that could fill in those blind spots? A lot of these are days where data before COVID, data has become quite less valuable. Some degrees, data has changed so much. People are moving around quite a bit. Demographics have changed. A lot of previous models will need to be rebuilt. So I think it's an incredible opportunity to use the guideposts that you laid out in the paper, but also your simpler techniques that can quickly learn to bias in the data. I'm going to ask one question around post hoc explanations, and it dovetails. I think someone, Alfred from audience, asked a question around can Raghu chime in on Shapley values informs an average marginal contribution of a feature value. What measure or statistics would be, in your opinion, closest cousin in traditional credit risk scorecard modeling?
I don't know if I can go into the very specifics of that within the next 5 minutes, but the objective of the postdoc explanation section was to really bring into a picture not just Shapley, but also Lime, also ALE, also many other methods, and then juxtapose it with how the locality of the and the globality of what you're observing is taken into account. So what I mean by that is, let me try to give a more basic example. So if I am being evaluated, so let's say I was declined, and I'm being evaluated for why I was declined in the top ranking attributes, and you have these model agnostic as well as model specific methodologies. So let's say you are using tree shape versus some other more model agnostic methodologies. It becomes very important how you look at what are the top contributing factors based on each of these methodologies, rather than coming up with a method, a specific metric. I don't know if that helps, but that's my take on it.
So, you know, an analogy here is that there are, people might get a kick out of this, there are 60 14,000-foot peaks in Colorado. And so if you're standing there, it's hard to decide which one's the highest, because you got to choose one from 60. And if somebody asks you what's the highest peak in continental United States, you know, the answer is actually it's in California, it's Mount Whitney, right? So, you know, that's why you have to use a variety of techniques, and it also depends upon your data. So look at your data and, you know, do your analysis in a robust manner.
Goes back.
And, you know, that's always going to get you there.
Goes back to Nick's point, Googling the data is a row by row, or at times value by value.
I just really quickly, and I promise I'll be really quick, I can say there is Shapley value regression, and I'm Googling for the reference right now. So that's a more just direct answer for that question. But I think that all the context that came with it is highly appropriate, because, you know, it doesn't matter if you're doing Shapley regression or deep learning, or there's still all these basic process and data concerns that you have to take into account.
Yeah, and Shapley regression's been around since I was just looking at
2001.
the original paper. Oh, okay.
That's my guess.
Well, the original.
I'm claiming 94.
Okay, all right.
The original Shapley actually came out in the 60s, right? If you're not wrong, the original Shapley paper.
Yeah.
Then so the regression was somewhere around 90s or so, but, you know, I still believe that we need to have a more than Shapley evaluation here, but, you know, that's my personal.
This is why it took us so long to get the paper out.
Well, I think definitely getting the definition right was the important piece. I think it's still a beginning. There's a lot more to do. We have 5 minutes. I think probably go around the panel, ask for what was the most famous recent event that called fairness and bias into strong prominence in your mind. An example.
Oh, I'd love to go first. So I'm gonna pull a real AI example that doesn't necessarily immediately touch on bias and explanation, but I think everybody will see where I'm going here. So, in a recent NTSB investigation of the fatal Uber accident in Arizona, it was found that the AI driving the car wasn't aware of jaywalking. And you can read that straight out of the NTSB report, okay? So this is an unacceptable failure, right? And I think if we all take a step back and we're honest with ourselves, this is where we are with AI today, right? We're at the stage of like aviation where airplanes were flying into mountains and enough had to crash so that we could learn, not to fly into mountains and then figure out what the next failure would be. We're lucky to have people on the phone today, like Steve and Raghav, who are maybe like 30 years further down that journey, just because financial services are regulated and high impact and people pay attention. So there's lots of interesting things in the news if you look, and I'm going to stick with the self-driving car not knowing about jaywalking as my example.
I can go next. The example that Nick mentioned earlier about bias in healthcare and access to care for, was a massive one. Not just because it was my professor who wrote it, but I think we get lost in this space of not addressing how much bottom line impact that these models have, right? Like, I was really excited to do this paper because one of my personal passions is figuring out like access to capital, and that has a compounding effect for generations. But healthcare is one that really resonates with people, right? So understanding that if this model decided that you will not get treatment in this circumstance, this person might die, right? And it's easy as a data scientist to separate yourself from the bottom line result of what you're doing. I think that can happen, and I think there are some much lower stakes situations. But I think when we talk about access to appropriate healthcare or generational access to capital, these are things that like affect the bottom line of your life in no uncertain terms. Yeah. So I think one of the things that we talk about in our book coming up is understanding like the externality risk of your models. And it's super important to understand how big the blowout can be for the people, for not just the customers, but then the second degree network effects of what you're actually doing and what does that do to like systemic pressure, right?
Yeah, the science article got me involved in healthcare and in working with healthcare companies to work on their algorithms. And there is an area that is really essential. When one of the things in a lot of presentations I talk about is that the average net worth, or it might be median net worth of a homeowner is 80 times that of a renter. It's not because you bought a home and you suddenly become incredibly wealthy. It's because this is a generational effect. And your parents owned a home, they might have helped you get one. And their parents owned a home, their parents owned a home. Well, redlining was happening in the 70s, and it's implicitly still happening in some places. The African Americans and other minorities who were not allowed, like specifically not allowed to buy homes and get access to credit, their grandchildren and children are still being affected by this. On the flip side to it, and it's very important, is that people who are in debt have symptoms of PTSD if they're in excessive debt. So if you just give loans to people who really can't handle them, you're affecting them terribly. And PTSD, there's been a lot of evidence that that gets passed down to generations. So when I think about what I'm doing in credit, it's easy to make it zeros and ones. But these are decisions that Raghu and Steve and all of the people on the phone are making are going to affect people's lives for generations. And as I got into healthcare, it's the decisions that I'm making that my advice to my clients is either going to kill someone or help them live. And man, that's a lot of weight to have on your shoulders. And so then, some of those have been in the news, others have not, but it's something that I want to point out that if we do not focus on this, we're going to have a profoundly negative or positive effect on society. So think about it as you're building a new model.
Thank you, Nick, because I think that's something everybody needs to kind of walk away. We get excited about the algorithms and the data, and we really do need to step back and think about the effect we're having on society. And I would add, this is nothing new, right? I mean, I was like, oh, I got a good logistics story, the same issue, right? But what's changed is the availability of the data, and I mean it's right there for you, right? And the proliferation of just CPU, or you can crush anything at this point, right? And we have great products that you press a button and you get a model. Right, so there's this just proliferation of really advanced algorithms on data, and if you're not paying attention to the fabric of the data, the strengths and weaknesses of your algorithm, what you're actually trying to solve, the objective function, and how that objective function fits within whatever process you're going to stick it in, if it's underwriting or healthcare or anything like that, how the rest of it kind of bands into it, you're going to end up with adverse effects, right? And, I'll end there. Raghu, I don't know if you want to jump in, but, it's super exciting. I mean, this is 20 years ago, it was like, God, I wish I could do some of this stuff, and unfortunately it's towards the end of my career, and it's just like, wow, right? To have this power, have this data, and to really have these conversations about impact, not just to the bottom line of the firm, but society. It's really special. And Sri, thank you for setting this up.
So that's where I was going to go also, Steve. Thanks to Sri and all, him bringing us together. It all comes back full circle. It's a good segue. We didn't plan for it, but the more we talk about these, the more we understand as a community it's a win-win situation. So that's all I have.
We're just following the data.
I think data is, in many ways, a reflection of the system we've lived. Data is a Sanskrit word, as some of you may know, means to give. I think it gives light, imparts light on events, and I think as the famous statisticians we adore say, "In God we trust." Everybody else bring data. I think data is coming from a lot of history, and it's quite good. Democratizing credit has incredible value for the world. Democratizing health, and AI is powerful in the way it touches finance, insurance, and health almost directly. And we feel very privileged to be part of this journey and transformation that's happening in the global economy, but more importantly, each one of our personal lives. So thank you for joining us this morning. In some places, afternoon, others. But Nick, Raghu, Steve, Ben, and Patrick, thanks so much for joining us for this panel. Incredible.